General relativity, step by step. Last time I promised to evaluate this Riemann Christoffel tensor with 4 downstairs indices in a local inertial frame. And we'll see that the formula turned out to be a lot simpler than you might expect. Still pretty bad, but it's a lot simpler than you might expect. Okay, well let's just go. G alpha pi times. I'll try and write a bit more neatly. G alpha pi times. Well, I'm going to take my definition of the Riemann Christoffel tensor from here. So I'll just pinch in a little tiny bit. Di lambda, and then the alpha has turned into, that alpha there has turned into a pi here because I'm contracting on it. Beta mu by di x mu minus di, and then the alpha again has turned into a pi, beta mu by di x mu. And you remember that there were cross terms which I can ignore because they're 0 in a local inertial, in an elevator frame. There's me in an elevator. Alright, well let's just get on with it. Equals G alpha pi, and I'll do it in 2 halves. Di by di x mu of. Remember, this is a local inertial frame, so I don't need to worry about the difference between colons and semicolons. I'm just going to do it. A half. This is now, I'm going to expand the Christoffel symbol here using this formula here, which I had to remind myself of. G, superscript. I've got a pi, which is pi. I need to sum on something which is going to be a sigma, times di G, blah blah, di x blah, plus di G blee blee, di x blah, minus di G blee blee by di x blah. That's that term there. Minus, oh no, I need to put the derivative. Di by di x mu, which is this term here, of a half G, and I'll use the same. Oh, actually, well, let me fill this one in first. We've got beta and nu. We've got a di by x, we've got pi there, we've got pi there, we've got sigma there. Where does sigma go? Where does sigma go? You should be downstairs indices, not upstairs indices. The reason I picked that up was that that summation variable sigma has to sum, that's upstairs, so it's got to sum with the downstairs. This counts as downstairs anyway, but it's got to sum with downstairs indices here. It's easy to make this kind of mistake. Right. Sigma goes in the first place and the second place. But again, I want you to see how I recovered from that error, because I was going to write down a term like this, pi sigma, and then di by di x something, di G, and then a sigma upstairs as well, and then maybe a delta there. So you see, you can't sum an upstairs index with another upstairs index. That doesn't happen. It's got to be an upstairs with a downstairs index. So if you check consistency of tensor equations at every step, you pick up errors like that. Okay, what am I trying to do here? I'm trying to figure this term in. I've got my pi, which is there. I've got beta and a nu. So I've got a beta and a nu. It's got to be a nu and a beta, and here there's only one place for them to go, which is a nu and a beta. There it is. Pi sigma again. Di by di x G blah blah blah, plus di G blah blah by di x blah, minus di G blah blah by di x blah. We're summing over the sigma. The sigma's got to go somewhere. Where does it go? It goes in the first place, it goes in the second place, it goes in the bottom. What else have I got left? I've got a beta and a mu. Here I had a beta and a nu. Here I've got a beta and a mu. So it's a beta and a mu. A beta downstairs and a mu there, and beta and mu together. And I better close my bracket there. Now what is this monstrous thing here? That is the Riemann Christoffel tensor with 4 downstairs indices as evaluated in a local inertial frame, in an elevator frame. And this is 5 minutes long already, so I'm going to stop here and I'm going to simplify it in the next one. Stop, 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 stop.